We're going to look at graphing tangent and cotangent today. Tangent and cotangent are different than sine and cosine. First of all, their period is pi rather than 2 pi. That's our first difference. Okay. Also, both your tangent and cotangent have asymptotes. Tangent is the only parent graph of your trig functions that does not start at 0. Your tangent straddles the y-axis. So our y-axis is right here, and the parent graph straddles it from negative pi halves to positive pi halves. Okay, so we're going to look at transformations. Now notice our parent graph kind of looks like an x cubed. It's bounded by these asymptotes still, so it's not really an x cubed shape. It just has that shape in this vicinity that we're used to seeing. Okay. Now, the period, instead of finding it by doing 2 pi divided by b, we find it by doing pi divided by b. Now, with the tangent, I think it's easier to use a different way than factoring out the b value and changing the horizontal asymptote, changing the horizontal shift from our starting point, because our starting point is no longer at 0, it's at negative pi halves. So this way right here helps us find both the horizontal shift and the period change. So we can use this to help us find these values. You could do the same thing for sine and cosine. I have not done it that way, but you could theoretically do the bx minus c, but you would do it 0 and 2 pi because that's where sine and cosine start. Okay. Also, there's not asymptotes at 0 and 2 pi, so there's still values there, so that's a little bit different. Okay. So you're going to take that whole thing inside your tangent function and then bound it by your negative pi halves and pi halves, and then you're going to solve. So in the case of this one here, we're going to, sorry, it's a little blurry. We're going to set the 2x in between negative pi halves and pi halves. Okay. So what I'm trying to do is get this x by itself. Well, this x is being multiplied by 2, so I want to undo the multiplying by dividing by 2. Well, dividing by 2 is the same thing as multiplying by a half. So because I have fractions on these other sides, I'm going to choose to write it as multiplying by a half. So 1/2 times negative pi halves is negative pi fourths, because remember, to multiply fractions, you do top times top over bottom times bottom. So 1 times negative pi is negative pi, and then 2 times 2 is 4. So here we're going to do pi times 1, which will give us pi, and then 2 times 2, which is pi fourths. Notice since they're the same numbers, you're just going to have a negative here and a positive here. So now our asymptotes, instead of being at negative pi halves and at positive pi halves, it's now switched to negative pi fourths and pi fourths. And notice the distance between negative pi fourths and pi fourths is the total distance of pi halves, which if we look at our b value, this is the a, b, and then we don't have a c, so there's no horizontal shift, and there's a t. If we find the period, remember the period is pi divided by b. So our our b value is 2, so then our period is pi halves. So the distance from negative pi fourths to positive pi fourths is the distance of pi halves. So if I look at my scale here, I've got 3 tick marks as pi halves, so I want to go half that distance to get to pi fourths. So if I'm going half of 3 tick marks, that means I'm going to go 1.5. So then this distance is going to be pi fourths. I need to make some tick marks going the other direction. So this would be negative pi halves. Oh no, I need 3 of them. Just kidding. So I'm going to do one more, and then that's negative pi halves. So then our asymptote is going to be at negative 1.5 here. So there's our asymptote, and here's our asymptote. So that's negative pi fourths. Okay. Now, your tangent graph, we still have 4 sections and 5 different points that we want. So one of our starting points is the end asymptote on the left side, and the other one of the 5 tick marks is the end asymptote on the right-hand side. So I'm still cutting this section into 4 different sections, which allows us to have 5 tick marks, these being 2 of the 5 tick marks. So if I cut this distance in half here, in half would be at 0, and then half of that would be like here and here. Okay. Now it's not really called an amplitude with your tangent and your cotangent graphs, but you're going to use this point of inflection to help us start our graph. So that is the point that is at 0, 0, and it will get shifted with your horizontal and your vertical shift. Again, it would be the horizontal shift with any B value factored out of it. In this case, we don't have a horizontal shift, but we do have this vertical shift. So it's going to be right here, and we're going to be up 1. Now, because I have already manipulated my asymptotes, this middle tick mark that I have is already going to have the horizontal shift embedded in it with the period change. Okay. So then here at the middle, I'm going to go up by 1. So our point of inflection is going to be up at 1. So then we've got this point here. And since tangent, the parent graph, is like a positive x cubed, we're going to go right by a tick mark and then up 1. So this distance here, I didn't draw that well. This distance here is like your A value. Okay, so I'm going to go over a tick mark and then up by whatever the A is, which in this case is 2. So over a tick mark and then up 2. And then since it's like a positive cube, we're going to go left a tick mark and then down by 2. So then this is our value here. So then it's going to look kind of like that. Again, it's cyclical, so it will repeat itself over and over. I do not need to do more than 1 period. 1 period is fine. So if we look at this one, we're going to set that same thing, so that inside thing, that bx minus c or plus c, whichever one it is, and we're going to bound it by pi halves and negative pi halves to find out where our asymptotes are. Okay, so here we've got a horizontal shift, but not a period change, because we've got this is our C value and then our B is an unsaid 1. As opposed to this one, we had a period change, but not a horizontal shift. So here I want to undo the the adding pi by subtracting pi. So if I do negative pi halves minus pi, that gives me negative 3 pi halves. And remember that you can just take your calculator and you can do negative 1/2, so you do without the fractions, and then subtract 3 halves, and then you can, or no, 3 halves, 2 halves, or subtract 1 is really, 2 halves is the same as 1. It'll give you the same thing. And then you can math frac it if you want. Okay, I'm just hitting all sorts of wrong buttons. So you get your negative 3 pi halves, and then when you go back from your calculator, just make sure you put your pi into it. Okay, so then if we do 1/2 minus 1, that gives us a negative 1/2, so negative pi halves. Okay. So I'm going to move my y-axis to there. I'm going to call that 0. And then I'm just going to go 2 tick marks is pi halves. So that's negative pi halves. So this would be 1/4. Oh, and then I wrote pi, not pi halves. Okay. So 1/4, 1/2, negative 3/4, negative pi, negative 5 pi fourths, negative 3 pi fourths. 3 pi halves. Goodness gracious. Sorry. Okay. So then my asymptotes are going to be at negative 3 pi halves, so here, and at negative pi halves, so here. So then I'm just going to look at my amplitude and my vertical shift. In this case, our vertical shift is none, so I haven't shifted up or down at all. So I'm going to take this space here and I'm going to cut it into fourths. So I'm going to cut this amount in half and then in half again. So in half is at pi and then half and then half. Okay, so notice we've got 5 tick marks, 1, 2, 3, 4, 5, 2 of which are the asymptotes. Okay. So I'm going to go to my middle my middle tick mark, and then I'm going to go up or down by my vertical shift. In this case, we don't have a vertical shift, so that means that that point of inflection is right here. So then we're going to go over a tick mark, and then we're going to go up by the A value, which in this case is 3 halves, so up by 1 1/2, so it's going to put it right here. Then I'm going to go to the left and down by 1 1/2. And then I'm going to create that cubic-like shape and pull towards my asymptotes. Okay. Remember that this will repeat, so we're only doing 1 period, but it will continue to repeat. Okay, now let's look at one where you have both a period change and a horizontal shift, okay, or a phase shift. Okay. So here, this is going to go in the opposite direction, so it'll go right. It's not really by pi fourths because the 1/3 is embedded into the pi fourths. So we could factor out the 1/3 like we have on our sine and cosine. I prefer to just do the 1/3 x minus pi fourths is less than negative pi halves. Not as less than. I was writing this less than sign, but not saying it in the correct direction. Pi halves. Okay. So here, when we're undoing this, remember you do your order of operations backwards. So if we've got our please excuse my dear Aunt Sally, purple elephants marching down a street, PEMDAS, whatever you learned, we need to undo the add subtract first. So here I'm going to add the pi fourths. Okay, so if I do pi halves plus pi fourths, that gives us 3 pi fourths. And then I still have that 1/3 x. And then if I do negative pi halves plus pi fourths, that gives us negative pi fourths. Okay. So now that we've taken care of the add subtract, now I need to get rid of any multiply divide. So this 1/3 is being multiplied by the x, so I want to undo the multiplying by dividing by 1/3, but dividing by 1/3 is the same thing as timesing by 3. So I'm going to times all of these parts by 3. So then this gives me negative 3 pi fourths is less than x is less than 9 pi fourths. Okay. So again, I can rescale this because we're at 2 1/4 and then we're going off a little bit, or you can keep it as is and just go off the graph. Since I haven't showed you going off the graph, we'll go off the graph on this one. So notice here, pi halves is 3 tick marks. So 3 pi fourths is going to be halfway in between there. So it'll be 1, 2, 3, 4.5 tick marks. So we're going to just go 1, 2, 3, 4, 5 tick marks. I did not make them super equal, but that's fine. We're just attempting to do that. And then 1, 2, 3, 4. So when I go to create my negative 3 pi fourths, again, I guess I could label this as negative pi halves. For the third one is negative pi halves. So then this, we're going to go halfway in between, which will be 1.5 tick marks. So then 1.5. So that puts me here. Go red for our tick marks. So this is one asymptote. Okay. And then the other asymptote is at 9 pi fourths, which is the same thing as 2 1/4 pi. So we're going 1/4 more. Well, 1/4 is half of this amount because that's pi halves. So it's going to be 1.5 tick marks past it. So 1 and then a half tick mark. So my other asymptote is going to be here. So we've made it a longer period because of the 1/3, right? So our period is really pi divided by 1/3. So I'm going to flip and multiply. So then that gives us 3 pi. So if we look at the distance between negative 3 pi fourths and 9 pi fourths, that gives us a distance of 12 pi fourths between there, which is the same thing as 3 pi, which is what the period is. Okay. It also has our horizontal shift embedded in there because normally we're at negative pi halves as our normal asymptote, and then we're shifting to the right. Okay. So notice we're going past our 2 pi. So then, well, I guess past the 2 pi. No. Now we're going to go halfway in between this amount. This is large enough that I'm probably just going to estimate. So you can put your fingers at the beginning and the end and then run them towards the middle at the same rate. So I can't show you because I can only touch one place at a time on this, but oh, now I lost that point. Yeah, so about there. And then I'm going to take this distance here and I can go half that amount. And then I can take this distance here and go half that amount. Okay. I don't need to be super precise. I need to tell that you're trying to go about a half. And then since this is shifted down by 1/2 at our middle tick mark, we're going to go down by 1/2. So right here. And a negative tangent, so if our positive tangent is this, then our negative tangent looks like a negative cube. So I'm going to go over 1 tick mark and then up the amplitude, not the amplitude, up the A value, which is 1, but then we have the negative, so then we're going to go down 1. So we're going to go down 1 from 1/2, which is at negative 1.5. And then I'm going to go left a tick mark, but then I'm going to go up by the A value, which in this case is 1. And then we're going to have, so this one got stretched nice and big. Or I could have rescaled. Right? That's another option I could have done, rescaled my tick marks.